Hello, this is Kuntal Chakraborty, Assistant Professor of Electrical Engineering Department, Greater Kolkata College of Engineering and Management, GIS Group. I'm just going to give a lecture on an important topic, that is 8085 microprocessor programming. I already discussed different types of instruction sets like data transfer instructions, arithmetic instructions, logical instructions, branch instructions in my previous lectures. So by using this kind of instruction sets, we will try to write some program, and we will try to learn how to write some program by using this lecture. So first we will try to write a program by 2 8-bit of data addition. So addition of 2 8-bit of data. So this is a program by which 2 8-bit of data that can be added. So now here the two data that is stored from location 2100 and 2101H. So now we will initialize this address 2100 by writing into HL pair. So 2100 that will be stored into the HL pair by instructions LXI. We will initialize it, and we will take C for the carry, and we will initialize this register by writing 00 by using MVI instructions. And next we will take a register B, and we will initialize it by writing 00 here. Next, MOV A, M, the content of M means 2100 that will be stored into the accumulator. Next, INX H means the HL pair that will be incremented by 1. Now the address is 2101H. Now we will add M, means the content of accumulator and content of the memory, that is 2101, that will be added, and the result that will be stored into the accumulator. And here we will check whether the carry is generated or not. So that's why we will use an instruction, that is JNC, that is a branch instructions. And if the carry is not generated, then the program sequence that will be transferred here into this loop. And if carry is generated, then the C register that will be incremented by 1. And again, now the result that is stored into the accumulator, then that will be stored into the B. And next we will increment the register pair HL by 1, and now the address is 2102. And the result that is stored into B that will be now moved into M, means the result stored in B that will be copied into next memory location 2102. Now we will again increment the register pair HL pair by 1. So now the memory is 2103, and if the carry, the content of C, that will be stored into the next memory location. So that is the way by which we 2 8-bit of data that can be added. So next we will try to write a program where 8 8-bit of data that will be addition will be there. And here for this addition, the data that is stored from 2100H locations. So first data that will be stored into the accumulator, and next data that is stored from memory that will be added with the content of the accumulator. So that's why here we will need 7 additions. 7 numbers of additions will be there. So we have to add 8-bit of 8 data, and the addition that can be that will be done 7 times. So that's why we have to make the counter for 7-time addition. So now first we will initialize it by the address there, writing into the HL pair, that is 2100, that will be copied into HL pair by using LXI. Now we will basically we will create a counter of 7 by writing 7 into the register B, and we will take C for the carry 00 that will be stored into the carry. Now the content of M, that is 2100, that will be stored into the accumulator by using MOV, and we will increment the register pair HL so that the address that will be incremented by 1. Now we will use add M, and here the content of A and the content of memory, that is 2101, that will be added, and result that will be stored into the accumulator. Now here we will check whether the carry is generated or not. So if carry is not generated, then program sequence that will be transferred here, otherwise that will be incremented by 1. Now here in this loop, actually the register pair, HL pair, that will be incremented by 1. So it means the address that will be incremented by 1. So now here one addition operation is completed. Now we will decrement the B register that holds 7, that will be decremented by 1, so that will be 6. And at that time, JNZ check whether B is 0 or not. As B is non-zero value, then the loop program transferred sequence that will be transferred here, and again addition that will be made, and this loop actually continues 7 times. So at the end of this loop, when the B that will contain 0, at that time it will check the JNZ whether it is non-zero or not. As it is 0, so there will be no loop operations. Now the content of A, that is the result stored in accumulator, that will be stored into the M. I already incremented the data by using INX H in the loop, so that's why here already address that is incremented by 1, so the content of A that will be stored into the memory. Now again it will be incremented by 1, so the carry is a results part also, then this content of the C that will be stored into the next memory location. That is a way by which the multiple 8-bit of data that can be added by using this kind of program. So in this program actually we add 8-bit of data. So next we will try to multiply 2 8-bit of data. In 8085 microprocessor we don't have any direct instructions by which the multiplication that can be done. So we have to make a way by which we can multiply 2 8-bit of data. Say example like if you want to multiply 2 with 5, so if we add 5 by 2 times, then that will be 10. Similarly 2 into 5, that will be equal to 10. So if we write if we multiply 10 with the 5, then that will be equal to 50. But if we add 10 by 5 times, we add 10, then that will be also 50. So by addition we actually try to multiply 2 8-bit of data. So that's why we will initialize 2100 that will by writing HL pair. So 2 data that is stored in 2100 and 2101H. So now here we will also take a register C for the carry, and we will take another register B for the counter. So one of the data that will be stored here. So the first data 2100H, the content of 2100H, say that it is 5, so that will be stored here for the counter purpose. So the 5 that will be stored into B. Now again we will increment H. So now the content of 2101, so say that is 10, and that will be added with the content of A. Say initially the content of A is 0, so 0 is added with the 10, so the result that will be 10, and that will be stored into the accumulator. Now here for this addition we will check whether carry is generated or not. If carry is not generated, the program sequence that will be transferred here. If carry is generated, then the INR that will be incremented by 1. Now here in this loop, the B that will be decremented by 1, here the B is 5, now it will be decremented by 1, means that will be 4, and as it is non-zero value, then JNZ that will check whether it is non-zero or not. As it is non-zero, then the program sequence that will be transferred here, again the addition that will be done, and again it will check it will be decremented. B that will be decremented by 1, now it will be 3, and at that time it will check whether B is non-zero or not. As it is non-zero, then again the loop that will rotate. So 5 times that loop will rotate, and when the B is 0, at that time the loop will not continue, and we will increment the HL pair by 1, and the result that is stored into the accumulator that will be stored into the memory, and the carry that is stored into the register pair, again we will increment the register pair HL, and the carry that is stored into the C register that will be stored into the next memory locations by using MOVMC. So that is a way by which 2 byte of data that can be multiplied by using 8085 microprocessor. Next is a division of 2 8-bit of data. So here two data that is stored in 2100 and 2101H. So here the 2100 is initialized by HL pair, and now the content of M that will be stored into B, say the content of M is 45, that is stored into B, and 00 is initialized by writing into C. So we initialize the C register by 00. So here the C is used for the carry also, carry purpose. So now here INX-H is occurred, means the HL pair that will be incremented by 1. So now next address is now 2101. So next at the data of the next address is say 10. So now we will copy the data into the accumulator. So by using MOV A comma M, so the 10 that will be stored into the accumulator. Now we will compare the content of B and the content of A. The content of A is 10 and the content of B is 45. Now we will compare as A is less than greater than less than B. So that's why the no carry is generated here. So it will not transfer its loop sequence here. So so that's why we will subtract B from A. Now the data is 35, and that will stored into A, and that will be transferred into B by using MOV B comma A, and at the time it will be incremented by 1. Now again jump loop 1, the loop 1 again continue. So now the content of A is stored from the memory, first memory, that is 10, second memory, that is 10, and here the content of B is 35 now. Now 10 is compared with the 35. Now here the 10 which is less than 35, so that's why no carry is generated. So now subtraction made means 10 minus 35, now the result is 25, and the 25 that will be stored into B by using MOV B comma A, and here the inertia occurred, and that will be 2, and next again the jump that will occur. Now here the 25 holds B, so now content of M, that is 10, that will be stored A, and here the B actually holds 25, and here 10 is basically less than 25, so no carry is generated. Then again subtraction that will be made, and the result will be 15, and that will stored into accumulator, and that will be stored into B by using MOV instructions. Again it will be incremented by 1, so that will be 3, and the again jump that will occur, and now the content of M, that is stored into A, that is 10, by using MOV A comma M, and again it will compare with the content of B. Now the content of B is 15, so now 10 that is compared with the 15, and as 10 is less than 15, so no carry is generated at this time. Then again subtraction that is made 10, so the result that will be equal to 5, and that is stored into the accumulator, and that will be stored into the B by using MOV B comma A. So again increment occur, then it will be incremented by 1, so that will be equal to 4. So now again jump occurred to this loop, and now it will compare, that is the content of M that will be stored into A, that is 10, and it will compare the 10 with the content of B. Now the content of B is 5, and here the 5 is less than 10, so the carry is generated. So the operation is already completed. So that's why B actually holds the remainder, and C actually get the result from the C. So the it will in the program loop that will be transferred here, the program sequence that will be transferred here as the carry is generated. So here the INX-H will occur, the register pair, HL pair, that will be incremented by 1. So in the next address, the data that means C, that is 4, that will be stored into the next memory location. Then it will be again incremented by 1, and the division, the remainder that is stored into B, that is a 5, that will be stored into the next memory locations. So we don't have any division instructions in case, direct division instructions in case of 8085 microprocessor. So that is the way by which 2 8-bit of data that can be the division of this 2 8-bit of data that can be done. So that is the way by which we can perform the division operations. And next is the subtraction of two 8-bit data. So that is stored into 2000 and 2001. So first the data store, we have to initiate the HL pair by writing 2000. That will be the address initiation. So after that, the content of AIM that will be stored into the accumulator, and we will increment HL pair so that the address that can be incremented by 1, and the content of AIM that will be stored into B. Now here we will take C for the carry purpose, and it will initiate it by 00, writing 00 into C register. Now we will subtract subtraction that is made by using this instruction SUB, that will be subtracted in between A and B, subtraction done in between A and B, and the result that will check whether the carry or borrow is generated or not by using JNC. So if the carry is generated, then INR C that will occur, means the C content of C that will be incremented by 1. Otherwise, the program sequence that will be transferred here, and the HL pair that will be incremented by 1, and the result that is stored into the accumulator that will be stored into the next memory locations by using MOV M, A. Then it will be incremented by 1 by using INX H. Now the address again it is incremented by 1, and the content of C that will be stored into the next memory location by using MOV M, C. So that is the way by which the two 8-bit data subtraction that can be made. Next, the 216-bit data addition. So here the first 16-bit data that is stored into 2100 and 2101H. So lower byte of data that is stored into 2100 and upper byte that is data stored into 2101H. And next 16-bit data that is stored into 2102 and 2103H. Lower byte of data that is stored into 2102 and upper byte of data that is stored into 2103H. And here we will first try to get the data that is stored into lower byte of data that is stored into 2100 into accumulator by using LDA instructions. So the content of A 2100 that will be stored into the accumulator, and we will move that data into the B registers by using MOV instructions, and then we will try to get the data of the next 16-bit data's lower byte that is stored into 2102H. So that lower byte of data that will be stored into accumulator by using LDA. Now we will add the data with the content of A and B. So first lower byte of data that is added, and the result that will be stored into the accumulator. And here the content of the A, that is the result of the lower byte of data, that will be sent to the next memory locations 2104 by using STA. So here by using STA, the content of A that will be sent to 2104 locations. Now next the upper byte of data, first upper byte of data 2101 for the first 16-bit of data that will be stored into the accumulator, and we will move the data into the B by using MOV B, A register. And LDA 2103, that is the next upper byte of data of next 16-bit data, so that will be stored into the accumulator, and we will use add C, ADC, so that add with the carry that can occur with the content of A and the content of B. The first addition, it may have any carry, so that carry that can be added with this content of A and content of B, and the result that will be stored into the accumulator, and that will be sent to the next memory location by using STA, the content of A that will be sent to the 2105. So that is the way the 16-bit addition that can be made in case of 8085 microprocessor. Next is the largest number of data from 10 set of data. So basically the data that is stored from the locations 2100H. So we have to find the largest number from the 10 set of data. So that's why we have to make a counter here also. So first we will initiate the address by writing it into HL pair. So 2100 that will be stored into HL pair, and that is the initialized address. And we will set the counter as 10 by writing A into B. So B is actually set as a counter, and the content of M that will be stored into the accumulator first by using MOV A, M, and we will increment H again, and the data that is stored into the accumulator that will be compared with the content of M. If the A is greater than the memory, then the loop, it will check the JNC, the carry is generated or not. If A is greater than memory, then the carry will not generate. So at that time, the program sequence that will be transferred here. And if the A is less than memory, at that time the memory is higher than the A, so that's why the content of M that will be stored into A. Otherwise, DCR B occurred, means the content of B, that is the A, that will be decremented by 1, means that will be 9, and at that time it will check B is non-zero or not. So J and Z basically check B is 0 or not. So here B is 9. So now the loop 1 that will continue, the program sequence that will be transferred here, and again it will incremented by 1 and it will compare the content of A with the content of memory. And if it is A is greater than the memory, then the program sequence that will be transferred here. Otherwise, if the memory is greater than A, then the content of M that will be stored here, A into A. And this is basically, this loop is actually continuing up to 10 times. And when the B is 0, after decrementing the content of B, when the B is 0, J and Z check whether B is 0 or not. If it is 0, then the loop 1 that will not continue, and the A that will be stored the largest number. So now we will increment the HL pair so that the next address that can be incremented, and the content of A that will be sent to the next memory location. So that is the way by which the largest number that can be found from a 10 set of data. Now the smallest number of data from the 10 set of data, we have to find out the smallest number from a 10 set of data. So that is similarly the data that is stored from 2100H. So first we have to initialize the address by writing into the HL pair. So we will use LXI HL H, 2100. So 2100 that is stored into HL pair. Now we have to create a counter here. So A that will be stored into B. So previously that is also created. So here the B is stored A. So 10 times we have to check the data, as 10 set of data we have. So now the content of M that will be stored into A, and next is the INXH. So if you write INXH, that is HL pair that will be incremented by 1, and we will compare the content of A, that is 21000, and next memory 21001, and it will compare whether A is less than M or not. If it is less than M, so the carry is generated. At that time loop that will be transferred here, and if the A is greater than M, then the M that is smaller than the A. So I mean the content of M that will be stored into the accumulator, and at that time if it is not occurred, the loop 2 that will continue, that is the DCR B. The B content of B is A that will be decremented by 1. So at that time that will be 9, and J and Z it will check the whether the B is 0 or non-zero. So as it is 9, so that is a non-zero, then the loop 1 that will continue. So this loop that will actually continue 10 times, and it will try to find out whether the content of the accumulator is less than M or not. If it is less than M, then the loop 2 that will continue, and if it is not less than M, then the content of M that will be stored into A. So finally the smallest number that is stored into the accumulator. So if the after the final loop, the B that actually holds 0, so now J and Z that will check the B is 0 or not. As it is 0, then loop 1 that will not continue, and INXH that is the HL pair that will be incremented by 1, means the address that will be incremented by 1. So the data stored in the accumulator, that is the smallest data, and that will be sent to the next memory locations, that is by using MOV M, A. So the content of A that will be sent into the M. So that is the way that the smallest number that can be found from a 10 set of data. So next is BCD to hex conversion. So here we have a BCD number that is stored into 2100 and 2101H. The MSD is stored into 2100 and 08, that is the LSD, that is stored into 2101H. So total data is 28 basically, and if you convert into hexadecimal number, then the data output will be 1C. So now first we have to initialize this by writing 2100 into HL pair, so the address that can be initialized. So after that, the data that will be stored into the accumulator. So here the data is basically 2. So in this BCD to hexadecimal conversion, what we have to do is that MSD that will be multiplied by 10, and that will be added with the LSD and the data that can be converted into hexadecimal form. So here we will first try to multiply the MSD by 10. So first we will take the content of MSD into the accumulator, and we will add A, means that it is multiplied by 2, and the data A that will be stored into the B, and again we will add A, means it is multiplied by 4. Again we will add A, then it will multiplied by 8. Again we will add B, so that it is multiplied by 10. So the 2 that is multiplied by 10 means that will be 20, and again we will increase the HL pair by using INX instructions. So HL pair that will be incremented by 1, so to point out the LSD. So here the LSD is 8, and we will add the LSD 8 with the content of accumulator, that is 20, that will be 28. So now the 28 basically the hexadecimal number 1C. So that is the way by which the BCD number that is converted into hexadecimal number. And this hexadecimal number that will be stored into the next memory locations. So that's why INX H will occur, then the HL pair that will register, that will be incremented by 1, and the result that is stored into the accumulator that will be sent to the next memory locations. So that is the way the BCD number that can be converted into hexadecimal number. So next we will try to find out hexadecimal number to BCD number. So here the example is 2100 locations, we have the hexadecimal number FE, and we have to convert into decimal number, and this BCD number is basically stored into 2101 and 2102H, and the data is stored in 2101, that is 54, and 2102 is 02H, and 02, and in 210201 is 54, and that 54 is the LSB and 02 is the MSB. Now we will try to write the program. So here the 2100, the hexadecimal number is stored in 2100. We will try to initialize this. So we will write 2100 into HL pair, and we will take the B register, and here we will initialize it by writing 0, and we will XRA A, it means the content of the accumulator that will be clear, and means that will be equal to 0, and the content of M, that is FE, that will be stored into the C register. Now here in this loop we are actually using ADI01, means the content of A and 01 that will be added, and it will then we will use DAA, that is the decimal adjust accumulator. So by using DAA, the accumulator is actually adjusted as a BCD number, and it will check whether carry is generated here or not. If the carry is generated, then the INR B will occur, otherwise it will transfer the program sequence into loop 1, so that will be decremented by 1. So DCRC actually occurred. The content of M that is actually FE that is stored here, so that will be decremented by 1, so that will be FD, and it will check the C is non-zero or not by using JNZ, and the loop that will continue until the C gets 0. So this basically when the loop continue, then again it will add 01 with the content of A, and again it will decimal adjust done by using DAA, and again it will check whether carry is generated or not. So this is actually continue the method, continue the loop 2 that will continue, and up to the C until the C make 0. So when it is 0, the operation is completed, means the hexadecimal number that is converted into BCD. So basically accumulator that is actually hold, this accumulator actually hold the lower byte of LSD, and the B register actually hold the MSD. So now this is the way the hexadecimal number that can be converted into BCD. So here we will STA2101H, it means the next data that is stored into the accumulator, that is the MSD, I mean LSD, that will be stored into the 2101H, and then the content of B that will be stored into the accumulator, and STA2102, the MSD data that will be sent to the 2102H. So that is the way the hexadecimal number that can be converted into BCD conversion. So thank you. I already discussed different types of programming by using 8085 microprocessor, and in this programming we already use different types of instructions, also arithmetic, logical, branch instructions. So by using this kind of example, so we can basically learn how the program of 8085 microprocessor that can be done. Thank you.